Hey guys, this is Smart Knob team. I am Hongyi and this is Hou Xuan.
So as described last week, our project is to build a knob with a BLDC motor providing like real haptic feedback. We 3D printed all the shells and cases inside supporting parts. We have built full functional prototype with breakouts with the BLDC motor and on board, realizing haptic function last week. And for ESP part, we used Platform IO to program C++ for controlling the motor and the screen. And our final goal is to build a full functional, good-looking knob, which can be put into actual use and additional function at any time. And so we are now at right after the milestone 3. We finished our full functional prototype last week, and we're now planning to build a whole new design for milestone 4. Which is more compact and can fully realize the functions we want, or even more than that, like to add functions after the hardware is set. And for design choices, after we build the full functional prototype, we decided to build a new design from scratch that is more compact and better looking. And overall design choice has not changed.
Okay, so let us show you a short video showing our fully functioning prototype.
Okay, so first, this is our smart knob, and we have 7 slots for haptic feedback, and you can see when I push it.
This is haptic feedback.
It stuck to one slot. Okay, now I spin about 360 degrees. That's haptic part.
And it is controlling the luminance of an LED.
Yep.
Over here. This is slot 0, and we can turn it
2, 3, 4, 5,
6, and go back to 0.
Yep.
Yeah.
And
this is the LCD screen.
For the LCD screen, it can show the exact degree of what we're pointing.
We can show the angle of the motor of the magnetic field.
7. Okay, and for the website,
it gives the LED level. Yeah.
3, 4, 5, 6. And this is all by spinning this. This is all by spinning this haptic knob.
Yeah, so that's our full
first,
prototype. Okay, and we have interviewed another person, and he says that we can make mass production optimization in all steps and see if this can be a commercial product. We can consider making it more user-friendly. For example, we can connect the knob to another larger screen of knob for the settings, like switching modes and just knob luminance. And there's one thing, so far there's one thing new to us, that is the simple FOC library in the Platform IO. It is the motor control library. So we need to go through a few steps to set up the controller. First, we need to set up the motor driver and the magnetic sensor or the encoder. And after that, we need to set up the just set up the motor and then link the motor to the driver and the sensor that we have set up before. And finally, we select a control type. We can select a velocity control or torque or angle control. In this prototype, we use the open loop angle control. And in the main loop, it's very simple. There's a loop FOC function and another function that actually move the motor. We move the motor to a 0 angle. That is the electrical angle. So we have 7 slots. Okay, so now we have 2 questions for you. The first is that we are now considering using the website to send a command to ESP32 to set the mode of the knob or calibrate the motor. Do you have any idea of how to send data from the website to ESP32? Because now we are able to send data from the ESP32 to the website. We want to do it conversely. Do you have any idea how to do it? Or does the reverse control make sense to you? Do you consider it a useful functionality? And the second question is, what do you think we should improve on our prototype besides what we will do on final product? So this is our presentation. Thank you, guys.
Thank you.